So, hello everyone. My name is Thomas Zimmerman. I'm from the Research and Software Engineering Group. Thank you so much for coming. Today we're going to have a presentation on boosting developer productivity, and it's going to be presented by Thomas Fritz. Thomas is an assistant professor at University of Zurich in Switzerland, and he actually was visiting us over the summer, and he is also closely collaborating with our group on productivity. And today he's going to talk about some of his work on biometric, like biosensors and productivity. So,
thank you so much. Thank you so much for the introduction. And thank you all for coming, and thank you for listening to this talk. I'm really excited actually to have this chance and opportunity to talk to you a little bit about my research on boosting developer productivity and how we can use personal data to revolutionize software development. But let me start out with my vision. So my big vision is really to make software developers more productive and happier. Now, you all know software developers, so you know that this is a long-term goal to achieve, and it's not that easy. But really, what we want to go is, like, we want to better understand software developers to help them in the end to become more productive. Now, traditionally, what we have done is mostly in the research community is that we've looked at what have developers worked on, what are the artifacts that they've produced, what is the code that they produced, so what have they done? And there's been some great research coming out of that. So there's been some great research on, for example, mining software repositories to then predict where the bugs are and support software developers in being productive. Okay. Now, we want to enhance this research, and we want to enhance that by better understanding what does it really mean for software developers to be productive. So how do they perceive their own productivity, and also to take advantage of persuasive technologies such as self-monitoring or goal setting to help them become more productive. So for the first part of this talk, I will talk a little bit about the developer productivity research that we've done in our group. But then afterwards, I will also move on to a different topic, because to really get software developers to be more productive and be happier, we don't just need to know what they've produced, but what they're experiencing in their work. So what are they going through doing their work? What are the difficulties that they're having when they're programming or when they're working on change tasks? And basically helping them by understanding that better. And so for the second part of this talk, I will talk to you about the research that we've done on the biometric sensing. So we've used biometric sensors to better understand what's going on in the cognitive and emotional states of software developers to then support them in being productive. And then at the end, I will briefly also talk about one of the projects where we've taken advantage of the insights that we've gathered in both of them, and that's what we call the focus light. And we've run a field study and helped 450 people basically be more productive. But let me start out with the developer productivity. Now, there has been a lot of research actually looking at productivity and understanding what productivity means. So for example, Watts Humphrey has defined this personal software development process where we had software developers manually tracking what they were working on, the time, the tasks, and so on, and trying to then help them to be more productive. Now, we want to enhance that by really also getting a feeling of what does it mean for software developers themselves to be productive? How do they perceive themselves productive? And also taking advantage of self-monitoring approaches and other persuasive technologies to make them or to enhance their productivity in the end. So to get there, we started out with trying to understand how does it work in the real world. Now, you all might be familiar with these activity tracking devices. Here's the Fuel Band or the Fitbit that track your steps. And there's a lot of people now, 20 million people approximately, and projected as 60 million in the next 2 years, that wear these activity tracking devices. And that's not even counting the number of people that have now the smartwatches or the phones to track their daily steps and their daily activity. Now, with this proliferation of these devices in the real world, there is really a chance for naturally studying them or for studying the use of these devices in a naturalistic scenario over the long term. So what we've done is we've started out with an interview-based study where we had 30 people that used these devices for more than 3 months and up to 4 years. And we interviewed them about their usage. And here's just some of the insights that we gathered. So one of them was that these devices really motivated durable change. So people, even after 4 years, still stated that they use the devices looking at the number of steps that they have and trying to keep up 140,000 steps per week, park their cars further away, or for example, always took the staircase instead of the elevator up. Now, at the same time, what we also noticed, so basically that shows us that it doesn't just motivate you to become more active in the first place, but it also helps you to stay on a high level of activity for long term. At the same time, what we noticed is that the awareness becomes extremely acute. So people really focus on these metrics, on the step count. So as they became more and more active, they also went to the gym and so on, and then they used different devices that they had beforehand. And for example, they used the treadmill and noticed when they, or not the treadmill, but the hill climb, when they went backwards on those things, that the step count wouldn't, that the activity measuring device wouldn't count it. So it became very extreme, and they basically cut out these activities that wouldn't help them to increase their count in the end. So what we noticed here is we really don't just need to understand or grasp a good metric in the beginning, but we really need to make sure that we support the changes that they have by becoming more active in the long term. Now the question obviously is, so this was in the naturalistic use of activity tracking devices, but then how does it help with software development? And so for us the question was, what does it really mean? What are these steps that we have for software developers? Is there any number that we can use, that we can just port over and show software developers to not just be productive, but be more productive and understand the productivity better? And so to do so, we addressed a couple of questions. So one of them is, what does it mean for, as I mentioned, what does it mean for software developers to be productive? How do developers today measure and assess, or want to measure and assess their own productivity? And how can we use that? How do developers improve their own productivity, and how can we use the insights to help them be more productive? Now, an important thing to mention here is when I talk about productivity, there's obviously a lot of notions of productivity. So there's this notion of business value and the outcome. In this talk, I really focus on the personal, the individual perception of productivity of the software developers. Because in the first step, we want to help them become more productive themselves, so provide them some self-monitoring. And later on, we might go into the other directions too, but for now, it's really the focus on this. So to address these questions, we conducted a set of studies. And the first thing that we did is we did a survey in which we tried to gain a broad sense of what it means to be productive, of how they assess their own productivity, how they perceive their productivity. And we had 379 participants. A big chunk of them was here from Microsoft, and another one was on a public survey that we had set up. And then we wanted to also understand how does it look in the field, like when we observe them. So we did in-depth observations. Basically, Andre did them. He is sitting here. He's one of my PhD students on the left. And he sat behind developers, logging every single action that they did for 4 hours of 11 participants in 3 different companies. And then finally, we also wanted to do that more long-term. So we developed a monitoring app that we installed on developers' machines, and where we tracked them in detail. So there was 20 developers that we had, and we tracked them for 7 to 20 business days, basically, on their computer. And at the same time, we also asked them periodically to log their own, or to report their own productivity, so that we can sort of assess when they're productive, when they're not productive, and so on. And we had 20 participants from 4 different companies. And I won't go into more detail on that one, but we also have done a follow-up study where we have now had 120 people actually that use the monitoring app for up to 6 weeks, where we've gathered more data, and we're still in the process of analyzing that. But here, just to show you some of the insights of that one, when we asked developers when they perceive themselves as productive, they said, well, I have a productive workday when I complete a lot of tasks or goals, so when I make progress on the tasks that I'm supposed to work on. And at the same time, when I have very few context switches and interruptions that distract me from my work. Now, there were other things like having no meetings, and people had mixed feelings about them. Some people considered meetings very positive. Some people considered meetings very negative. But it really differed based on the context of the meeting, on the setting of the meeting, how many people were in there, and so on. Overall, really what we found is that it really makes the most important thing is that people complete and make progress on their tasks and have very few context switches, very few disruptions or distractions from their work. Now, we also asked them to assess their own productivity and how they want to assess their own productivity. And we presented them 23 different metrics. And what we found is that there's one metric that most developers, or that was the most prominent one for all developers, the most positive one was the number of work items I closed, which is not surprising given what we found just before. But overall, based on the answers from the 380 people, for the 23 metrics that we had, it was always an individual combination of the metrics that somebody wanted to see to assess their own productivity. So it really differed by person what they thought was most important to assess the productivity of the day. So there wasn't one single best step metric in this case. Now, then we went on into the field and tried to observe them. Oh, sorry.
On the second one, the time I spend in meetings, you said there are different views about whether more time in meetings was productive versus less.
Yeah.
This is just a pure measure of it. It's not suggesting whether it's positive or negative.
Yeah, it's not. Like basically here we asked them, would you consider that as helpful for you to assess your own productivity when you see how much time I spend? And to be fair, it might be just like that. Some people don't have any feelings about, like mixed feelings. Some people think it very productive, so then they think it's good. Or some people think it's very unproductive, then that's also good because you see that you're unproductive. Good question, thank you. And so then we went over to ask them, or observe them in the field, and we captured a lot of data. So just to break that data down, we categorized it into different activities. So we have the different development activities, version control, debugging, coding, and so on. But you also have other activities such as the browsing-related, work-related information, browsing work-unrelated information, meetings, and so on. And here's a view of the 11 people. So you can see the 11 people on the y-axis from 3 different companies. So that's why the different letter in the first place. And here we captured them for 2 hours. So in total it was 4 hours, and the time varies a little bit. We did in 2-hour chunks, and based on their availability, it was sometimes a little more, a little bit less. But overall, you can see there's a lot going on. So let me just zoom in into one of them. So you see one of the developers as one, and you can see the developer does a lot of, like based on the categories that we classified them into, a lot of coding in the beginning, debugging. At some point, the person has a meeting, and then afterwards, he or she wrote and read a lot of documents, or worked on a document, and also started coding again. So overall, there was a lot going on. There was 148 activity switches. And in the background, you can also see these different grades of shades of gray. These indicate the tasks that they're working on. So when the shade of gray changes, that's when they switch between a task. Overall, this developer was working on 4 distinct tasks and switching between these different tasks 27 times over the 2-hour time period. So overall, there was a lot going on, and especially when you look back here, it's the same for pretty much everybody. Now, if you recall what we talked about before, and they said, I'm particularly productive when there are very few context switches, very few task switches, and so on. So then we were interested in finding out, did they feel particularly productive? And indeed, when we asked them, most of them felt very productive during the time that we observed them. And that is despite the fact that they had so many task switches, like 13.5 task switches per hour, and also very, very many activity switches, 47 per hour. So basically, every minute and a half or so, they were switching between a different activity again. And when we interviewed them afterwards, we also found out that it really depends on the type of context switch, on the cost of the context switch. So sometimes a context switch is not very expensive, and to stop and work on a and as people noticed here, is like to stop and work on a different task is a more costly context switch than writing a quick email. So sometimes they started up a test application and had to wait for the application to actually run. And when they would switch back and forth between email in that case, it would actually make them more productive rather than less productive. So sometimes it can be beneficial to actually have context switches, and really depends on the cost of it. And then some insights on what we did afterwards is we monitored them. So we wanted to see for a longer period in time. So that was for 2-hour or 4-hour time frames. So we installed this monitoring app on people's computer. And here's just sort of the breakup of the work from these 20 people. So as they're all developers, it's not surprising that they spend most of their time coding, 21%, and they spend a lot of time in email or browsing. And then when we looked at the differences between companies and between people, we noticed that there's a big change, a big variety in how much time they spend on each activity. So there was, for example, one company where developers spend only less than a minute per day on their email, because they also had a certain policy in the company to use emails just for certain topics, while others spend on approximately 75 minutes per day on email, like handling the emails and so on. And again, what we noticed is there's a really high fragmentation of the work that people experience or that people have when they're working. So every 0.3 to 2 minutes, they would switch between different activities. And then finally, we also looked at sort of like how do the productive times change over the day. And over those 2 weeks, we could basically cluster the developers that we had in 3 different patterns. So we had these people that were more productive in the morning, and some people that were a lot more productive in the evening. So they had this like low productivity in the morning and then the bump of productivity in the evening. And some people that were particularly unproductive at lunchtime and more productive in the beginning or at the end of the day. So really, it is a very individual thing, the productivity, and it depends on the developer when they like their tendencies of productive times and so on. So just to summarize that, what we found out is that when we looked at activity monitoring, there we can really support software developers in becoming more support people in becoming more active over a long period of time. So the question is, how do we bring that over? At this point, there's no single best step metric because it's always in a combination of, or an individual combination of different metrics that help software developers to assess their own productivity. But overall, what we found is it's really about making progress on your tasks and reducing these costly context switches that people have. Now, this really causes or poses the question, basically, how do we measure the cost of a context switch? How do we measure when people are very focused, for example, and not so focused? Well, traditionally, what we've done in the past is that we've really looked at asking people to manually write down what are you working on or what are you doing during your work. But that becomes really infeasible when you switch so often between the different activities, between the different tasks. More recently, Torridao has envisioned this framework for software developers to have already certain sensors installed and measure all of the things about the software developer. But as you can imagine, it becomes very difficult to be productive in this environment, especially because you have cold feet and whatnot. Now today, there's a huge opportunity because we have a lot more sensors available that are a lot less invasive and that can help us tell us something about the developer and about the cognitive and emotional states of the software developer. And so in our research, we want to take advantage of these sensors and really better understand what's going on inside of a software developer. What all of these devices are based on is this link between the physiological states or the physiological features and the psychological states. So for example, there was research that found that the higher the mental load, the slower the blink rate of the eye is, and as well the higher the pupil dilation is. So you can basically measure physiological features of the person by better understand what's going on inside. And you can imagine, preparing for this talk, I might have been a little bit stressed and then I start sweating a little bit more. And you can again measure the sweat to see something about the stress. Now the question that we have is, can we use that in the software development domain to make software developers more productive and better understand what's going on in there? So the basic question that we had is, can we measure developers' cognitive and emotional states to support them in their work? Now, sorry. If we're able to do that, we might be able to actually prevent mistakes at the time when they're being created, or before they're created and before they're committed to the repository, and we factor also cognitive difficult parts of the code. So if we know when people experience difficulties working on certain code elements, we can basically help them, interrupt them, for example, suggest taking a break, or suggest somebody else to read over the code and perform a code review because this was particularly difficult to change in the code, for example. At the same time, we might be able to measure the focus and the progress that developers have. And that, again, can feed back into the self-monitoring that I was talking about beforehand, where we can give them a better sense of how productive, how focused they were during their work. And then finally, we might also be able to reduce these costly interruptions, these costly context switches, especially like, for example, in-person interruptions by other people at inopportune moments. So when you're particularly focused on your task and it's particularly expensive to get out of the task. Now to do so, our vision is sort of like that we want to, in the long term, prevent bugs. So basically step in before the bug is committed to the repository and also reduce costly interruptions. And for that, I'll talk about 3 questions that we addressed in the recent past. One of them was, can we use biometric sensors or the readings from biometric sensors to predict the difficulty of tasks, or whether or not a task is easy or difficult? Can we use the biometric sensors also in the field over a longer period of time to predict code quality concerns, so the quality concerns that others have raised in code reviews. And then can we also use the biometric sensors to predict when interruptions are particularly expensive or not? For all of these approaches, or for all of these questions, we used a similar approach in the background. So what we did is we used multiple biometric sensors. So you can see the neuroskyte mind band to measure brainwave activity. And that allows us to capture brainwave bands, such as alpha, beta, gamma, delta, theta waves that people or researchers have previously, especially in psychology, have previously found and attributed to aspects such as visual attention, mental workload, and so on. At the same time, we also used electrodermal activity sensors, which are wristbands, and I could tell you something about the tonic and the phasic signal, and they can again be related or were correlated to general state of arousal and the surprise in literature before. And then finally, we often also used an eye tracker. And the eye tracker is interesting because it doesn't just tell you where people are looking at it specifically, but it can also tell you about the pupil dilation, so you get the exact location where they're looking at, and at the same time, sort of on the pupil dilation, you can say something again about the cognitive load. When we did these studies, what we had is we started out with several participants that used these sensors, and then we recorded the data either in the lab or in the field based on what the study was set out to do. We cleaned the data, so there's a lot of noise filtering that you have to do. You have to filter out invalid data as well. Then we used a sliding time window approach, so understanding or assessing or using certain windows of time of the biometric data to capture their state, and then extracted the features from the biometric data, and in the end, train a machine learning classifier to then see if we can predict aspects such as developers' perceived difficulty or the interruptibility based on the captured data and the features that we used in this case. So let me start out with the sensing of the task difficulty. That was the first study that we did, and we were really one of the first to actually do that in the field of software development. And that was with researchers here at Microsoft, Andy Bagel in particular. And what we had is we had 15 professional software developers come in here in a controlled lab environment, so a controlled lab experiment. And we had 8 small code comprehension tasks that were about 1 to 8 minutes long. And we varied these tasks based on, to stress different skills, so math and logic skills, working memory, but also spatial relations. And so here you can see the setup. We had the 15 developers, and you can see the 8 different tasks. These tasks, that's where the geometric shapes, these tasks were mostly either to ask them about whether or not 2 rectangles overlap, or in which order 3 or 4 geometric shapes were drawn. And then we assigned the task order to them randomly to mitigate any learning effects. And then what we have to do when you use biometric sensors, you also have to sort of gather or capture a baseline. So between every task, we actually would show them a 2-minute fish tank movie where they just looked at the fish tank. And the first minute was used to have them calm down. And the second minute was used to capture their baseline so that we could compare it against the task afterwards that they were working on. For this study, we used 3 biometric sensors. We used the brainwave band, we used the electrodermal activity wristband, and we used an eye tracker. And we captured multiple different features with these sensors. So here, for example, you can see for the eye tracking, we used the number of fixations, the number of saccades. From the EDA, we used the number of phasic peaks per minute. And from the EEG, we captured these different or extracted features such as the different brainwave bands, alpha, beta, delta, gamma, but also certain indices that have previously been linked to things like the task engagement, so beta divided by alpha plus theta, for example. And then what we did is we also had developers rate the difficulty of the task, so how difficult was the task. We captured how long it took them to complete this task, and we also had them answer a NASA task load index survey so that we could capture in the end how difficult the task was as well. And then finally, we then train a naive Bayes learning classifier using k-fold cross-validation. So here you can see, for example, the one time where we trained it on 7 tasks and then tried to predict the 8th task. We also did the other way around, trying to predict, learn on 14 people and predicting on the 15th person, and so on, to see how good we can actually use classifiers, train on other people for another person, or if we've seen everybody basically predicting for a different task that we haven't seen beforehand. And one of the major outcomes was really that this biometric data can really help us to accurately predict the task difficulty, so whether or not a task is easy or difficult. Now, that's one of the major things that we were interested in here, is because it was the first study, and there's obviously a lot of things that we can still improve based on the usage of the biometric sensors and also how we capture it and the filtering of the data afterwards, the cleaning of the data. But it was really an initial, or the first study in that field that showed us that it is useful and valuable to use these biometric sensors. And here you can also see, when we look at the different kinds of sensors or combinations of sensors, that the use of all three sensors, the eye tracking, EDA, and the EEG, was the best. But even just using the eye tracker performed fairly well in that case. So this was sort of like a very controlled lab experiment where we looked at people coming in here, sitting in a sterile environment. And the question is, can we do that out in the field? So what we did now is we ran a field study, and we had 10 professional developers, and we had them work as per usual on their normal tasks, on their normal change task. And in this case, we used two biometric sensors. So we used a wristband and we used a chest strap. We couldn't use an eye tracking because that was too invasive, and we didn't have enough eye trackers as well to set them up. But basically, we had them use that for 2 weeks, so on average 11.6 days or work days per developer. And then we captured the biometrics, but we also captured traditional metrics, because here the idea is to really look into, can we predict these code quality concerns? So code quality concerns being the things that people mention in peer code reviews, such as a bug in the code, such as not enough documentation or things that are difficult to read or understand and so on. So we captured these peer code reviews and the biometrics, but we also want to see if we can use these traditional approaches, something like code metrics, cyclometric complexity, or interaction metrics, or change metrics that have previously been used to predict bugs in the code and to predict bugs in the repository. And in the end, as I said, we captured these peer code reviews, but at the same time, we also captured periodically the difficulty that people had working on certain code elements. And here's just a little bit of how it worked. So people worked for 2 weeks on average. We had them have these sensors all the time. Like basically, we came in there in the morning, had them make sure that they worked, and captured or downloaded the data in the evening as well. Periodically, every 90 minutes, so we had something installed into the integrated development environment that would ask them about the elements that they were just recently working with, how difficult they rated them. We would also ask them, when they committed any change to the repository, how difficult some of the elements were, so basically random selection of these elements. And then at the end, whenever somebody peer code reviewed the code commit, we also captured the quality concerns that people had in there. And so just to say, at the same time, we captured the biometrics over the period of 2 weeks, but we also always captured the code metrics for each code element that they worked with at the time that they were working with, the interaction metrics, as well as the change metrics. And the outcome here was that in the field, the biometric data really outperformed the other traditional metrics in 3 out of 4 cases. So for predicting difficulty, what you can see here is the biometric is the purple one, and the traditional one are here on the left. And so basically, does better than the other ones. And when you combine the two, you also see that that's even better. So basically, biometrics really add additional value, add additional information to predict how difficult a code element is. So this was for predicting code difficulty. And at the same time, we wanted to look at how is it to predict really these quality concerns that people raised in the peer code reviews. And what we had here is that, again, the biometrics did the best overall. The results are not amazing in a sense that obviously it's you see the bold one shows you which one was the best for predicting quality concerns or no quality concern. And while the biometrics are the best, they're still not perfect. But you have to remember in this case again that that's the first time that somebody used it for biometric sensors for 2 weeks in the field. And obviously there's a lot to be learned on how we use these sensors, how we clean the data, and so on and so forth. But interestingly, it was so here you can see the code quality concerns, and there were overall in the 580 reviewed classes where they committed changes to, there was about 95 had quality concerns, and some of these were bugs, some of these were missing test cases, but also insufficient exception handlings and other things that we could predict in the end. So basically what I've shown you now is we had these 2 questions. Can we use biometrics to predict task difficulty? Can we use them to predict the code quality concerns? And we really found that we can do so in the lab as well as in the field. And that can help us with our long-term goal to prevent bugs, because by knowing when they're having difficulty, we might be able to intervene before they're committing it to the repository, or else we also prioritize code reviews. But let me pause you right here. Let me give you a short pause here just to regain some energy. So basically, this interruption isn't so bad because I might actually also regain your attention. So sometimes interruptions are bad, sometimes interruptions are good. And so for the last talk, for the last part of this talk, I'll talk about interruptions and how we try to look at capturing whether or not people are interruptible, what the cost of interruptions are, and also how we can help them to reduce the interruptions. So for this one, we did a similar study as before. But in this case, we had a lab and a field study. For the lab study, we had 8 graduate students. We had these lab students work on 3 different change tasks. And we used 2 biometric sensors. And then we had them rate the interruptibility at random points in time. For the field study, we had 10 professional software developers. And we had them work as per usual for 2 hours in the field on their normal tasks. And again, we used 2 biometric sensors. And we had them rate the interruptibility. Now, the way that it looked like in the field, here is one of the developers or participants of our study. And you can see that's the normal work setup that they have. But in addition, we had them wear the wristband sensor, which was the Impatigo A3 for capturing the electrodermal activity. And we had them wear the NeuroSky Mindband to capture their EEG data. And at the same time, we also set up this tablet on the right side, on the left side of the developer, that would trigger these random interruptions. And the way they would look like is, the first place, it would basically make a sound and tell you, okay, here's an interruption. Then the person clicked on start. They got an algorithmic exercise to basically distract them from the previous task that they had. And we asked them to rate the interruptibility. So interruptibility, but also the disturbance and the mental load. So we captured these ratings and also other things that I won't go into more detail here, but the resumption and interruption lags and so on. And in the end, the findings were, again, that these biometric sensors can be used in the lab as well as in the field to predict the interruptibility of the software developers. So interestingly, especially in the 2K state, we were pretty good at predicting the interruptibility of the developers and improving over the majority classifier. But for the 5 cases where we tried to predict a very fine-grained interruptibility of the developers, it was still working in the lab, but in the field with all the noise, it was not, did not achieve any improvement anymore. So just to come back to the third question is like, okay, so can we use the biometrics to predict interruptibility? Based on the lab and the field study, we were able to show that we can do so, especially in the 2K state. When we try to do it very fine-grained, then we obviously need some improvement still. Now, the question that you might ask at this point is, well, this is all nice, but how do you ever use that in the field? Or what can you do with that in the field? So yes?
Can I ask a question?
Absolutely.
For study A, or the first study you talked about, what was the improvement over the majority classifier? Did you find one?
So for this one?
For the first study in the controlled environment?
For the task difficulty? Or?
Yeah.
So the improvement, so we had 80% accuracy and the majority classifier would predict 56.
Okay.
So it's like the improvement, I can't calculate in my head, but there was an improvement basically as well. Big one. So how do we use this in the field now? And so here's one of the studies that we did now, which is a field study where we try to really reduce the interruptions that people have. So we call this the focus light. And what we did here is we designed this light. It's basically a USB board and with an LED light, and we put a ping pong ball on top of that, and we would change the color of that ping pong ball, so either in 3 different states. So we had available, so it would be in green. We had busy when it was red, and we had do not disturb when it was red blinking, basically similar to the Skype status that you know, or the link status that you know. And we calculated the interruptibility at this point based on the computer interaction that people had, and would then update the status of the light as well as the status of the Skype, so that people would externally be aware of what is the state of interruptibility of that person. We improved that over the time because that became because we had a lot of people to participate in the study and it was too expensive to actually produce them all the time. So then we used these LED lights. Sometimes we also put a ping pong ball over those ones as well. But basically what we had in the end is we had 449 participants or knowledge workers that we set up with these sensors from 12 different countries and 15 locations from one big company, ABB in this case. This is one of the field offices that we had where we tried it out. That was in India, and we had the whole office or the whole team set up with these lights, obviously enlarged the color of the lights. But we really went to all of these places, set it up with the people, and then collect the data from these people. What we did is we had them work as per usual, so we didn't basically do any specific thing. But we asked them afterwards when they used the lights for a specific period of time, so more than 5 weeks actually, to answer a survey. We had them also, 23 of them, we had in-depth interviews with them after 2 months of using the light. And we also had them self-report the interruption logs, and we got 36 of those that captured it. So here's sort of like the timeline. In the beginning, we installed the light. In the first week after installing, we didn't install light. In the beginning, we just installed the monitor to monitor the interactions and so on. And for some of the people that actually manually logged their interruptions, we captured the manually logged interruptions in this week. Then we set up the light. We left the light there standing for a week because there was a certain bias. When the lights were up, people would actually come over and interrupt you more often because they were curious about the light itself. They were interested, like, what's going on here? Why do you have a red light? Why don't I have a red light? And then talk about it. But then obviously in the week afterwards, then we again asked them in the post-install period to log their interruptions and capture how many interruptions they have per day. And then log the interruptions when they had an interruption actually. And then at the end, after 5 weeks, we mailed them a survey. And after 2 months approximately, we interviewed them in the field. So here's one of the outcomes, and there's multiple outcomes obviously because we gathered a lot. We gathered these surveys, the interviews, and the logs. But just from the manual interruption logs, we noticed that there's a 49% lesser interruption, or there's 49% less interruptions per person per day during these 2 weeks where we captured before and after. And there was a significant reduction in the number of interruptions that people had. And people were also stating that in the interviews and in the survey that this really created an awareness. And even for a long time, like even after the 2 months of when they had the interview, people were really still a lot more aware about the cost of an interruption. So if I go over, I shouldn't just ask them about my weekend if they are very focused, but I should think about when is the right point in time to interrupt them. And so another thing which was really positive for us is that even after, so we started out with 1 month or 5 weeks of usage, and that was basically the period of the study, but people kept using this device. And what you can see here is at some point in November 2015, like we started in July approximately, but in November 2015, we started tracking when they used the device or when they plugged it in, when they used it. And here you can see that up to September 2016, 75% of the users were still using this device on a daily basis. Now these peaks, that's because in the middle there are the weekends. All over the weekend they didn't use the device. And on the top you can see the different sites where we set it up. So in the beginning, one of the biggest sites in India, then Norway, Sweden, Vietnam, just some of the major sites that we had set it up with. So people really kept using this device, and there was more and more questions if others can also have a device. People really liked the device and even adapted it when they didn't like the ping pong ball, put up their own little light. And people who didn't get the device also wanted to have a light, and so some created their own pick chart, explaining, okay, 4 picks means that I'm busy or not, showing other people, and basically they were jealous of not having the light. So just to sum up all of this is I wanted to show you my research a little bit, or some of the research that we do, trying to make software developers more productive. I talked a little bit about how we can use enhanced traditional productivity research by really grasping what it means for software developers to be productive, and also using self-monitoring technologies or other persuasive technologies to make them more productive. And I've also talked a little bit about the biometric sensing, where we try to better grasp what's going on inside of a software developer, what are their cognitive emotional states. And one of the projects that we've done to really bring this together, and where we hope in the future to also use biometric sensors to be even better in terms of the accuracy of the interruptibility algorithm. Now all of this can really revolutionize the field and can really help us to reduce costly interruption. It can also help us to measure focus and progress that again then can be used for self-monitoring. And it can help us to prevent bugs, so not just predict bugs later on, but prevent them at the time when they might be created, and refactor cognitive difficult parts of the code. Now all of this research wasn't just done by me, but to a big extent by my great PhD students. And so these are the PhD students: Sebastian Müller, Manuel Züger, Katja Kewicz, and André Meyer, which you see in here, who have done a lot of the research, obviously. But a lot of this research wasn't just done by me and my PhD students, but it was also in collaboration with people from Microsoft. So Tom, for example, Tom Zimmerman and Andy Bagel, but also in other companies, David from ABB and also from the university. And to a big extent also by the professional software developers that worked with us on these studies. So we've worked with a lot of different companies to set up or to run these field studies. So this is the end of my talk, and I'm happy to take any questions that you have. Yes?
Fascinating. I really look forward to reading more of the details.
Thank you.
Do you have any thoughts, or did you study self-imposed interruptions? For example, is there a declining point where uninterrupted time loses its value? Loss of attention span. Mm-hmm. Is there a rhythm where people may want to interrupt themselves to refresh themselves?
It's a really good question. And it's a really, really interesting and exciting topic. So for now, we only studied the external interruptions by other people, or through Skype. But research has shown that you have approximately as many self-interruptions as you have external interruptions. And that's sort of where we want to go next, because one of the things that we also noticed is that people said themselves that the light would help them to be motivated. So when they saw that the light was green, they're like, oh my God, I'm not productive. So they actually tried to be more productive. Obviously, they gamed the system a little bit and tried to be red. Or when they saw that they were red, they tried to keep it or maintain it in the red and busy state because it told them, okay, I'm more productive. But obviously there's good and bad things. Like sometimes there's these techniques like Pomodoro technique, where if you interrupt yourself every 25 minutes and take a 5-minute work break, it actually helps you to be more productive afterwards. And that's something that we want to look at in the future as well. Good point. Thank you. Yes.
So I'd like to challenge a few of the assumptions that I've heard throughout the talk. And so let me start with the one that was there in the beginning, which is based on surveys and what people think makes them productive or not so productive, and sort of this connection to interruptions. I mean, fundamentally, right, so this is survey-based research, right, and so what gives you confidence that their perception of productivity is a reflection of reality according to somebody else? And I don't know, there are perhaps subjective measures. We can probably take issue with any number of them, but in many areas, reported preferences are just widely divergent.
No, it's a really good point. So what is a good measure of productivity? I wanted to point that out before, and what we really focused on is perception of productivity of the individual developer, because we want to help them to self-monitor themselves, to improve themselves. And we didn't look at other values. Like business value would be something else. How much do you produce? How many lines of code and so on? That would possibly be something else, but we really focused on the individual developer and trying to understand it. That doesn't mean that holds for every developer. And as we saw in these measures, everybody has different ideas of what it means for them to be productive. And I think that's what we found out in other studies too. It's a very individual matter what we consider as productive and not productive. Now, obviously, that doesn't help you to sort of assess the team productivity. And I think there's a new step that has to go in and see, can we abstract from that level and go one level up and see what does it mean for the team to be productive? So for example, one of the things that obviously comes up is when you're reducing interruption for one person, it might mean that the team is less productive overall. And so obviously we want to measure that as well, how much does it hinder that? The lights, fortunately, didn't hinder that too much, and people actually mentioned that, because even if the light is red, people would, if it's a high priority interruption, they would still interrupt them. But that's a different thing. So there's definitely another step of measuring productivity where we want to get it, but that's for the future to do.
How does this mesh with the idea of a 10x developer, right? So one person, productive days, another person, waste of time, frankly, right? So how does that all, I mean, you mentioned individual differences, but do you see that kind of range of individual differences anyway?
Do you see it? So I think there's a huge there's a huge difference, even just looking at meetings. So if you talk to managers, they find meetings particularly productive. If you talk to individual developers, not everybody. Okay, so I'd say, what I'm saying is there's very big differences in how I consider that. But if I help each individual to be more productive in their own ways, in the way that I hope that I help the whole team to be more productive. Obviously, if people have a completely distorted way of what productivity means, then I'm at a loss. But I think then, like, it's a general loss in general.
I guess what I'm trying to say is that given, I think different people's notion of what it is are really there's quite a broad range there. And so you're sort of really measuring their own perception or their relative perception to how they were yesterday or the week before. And there are a few absolutes in this picture you're bringing into this. This is kind of my challenge.
So, I mean, I'm curious to see if at some point, so obviously the longer we use it in the field, the more we also find out. And I'm curious if at some point something crystallizes that you can use. So, for example, you might be able to use biometric sensors to say, one of the things that always came up with, like, how long was I focused during the day? And that might be a good measure that could be used across different sites. Just as an example, I'm not saying that that's the best one, but that's like more abstract than, let's say, lines of code that I produced in a day, because somebody might create 10 lines of code, somebody else might fix bugs, and we've talked to them, and they use 3 days before they actually fix that one line of code and change that, and so there's obviously a huge difference.
So I'm wondering sort of how much these results would generalize. I mean, knowledge workers or anybody who has to sort of be in the flow, sort of load a bunch of context into their gray matter, really focus, and if they make mistakes, they're going to be bugs, whether it's in a worksheet or a C program, right? So I'm wondering sort of also, like, a lot of the techniques, a lot of the things you're looking at seem to be fairly general to a productivity worker at a workstation. But are there things that are attributes of the software development process that are sort of very unique, or would you pull out, or would you say that this is generalizable to, like, the knowledge worker working in a complex situation?
So it's a good question. So I mean, for the Focuslight, for example, we had 450 knowledge workers. It wasn't just software developers. There were 30% software developers. And when we started out, we only had software developers because we said we know when they're in the IDE, when they're debugging, then they're particularly productive. So we could sort of like measure that and sort of set the state more accurately. But eventually people said like, oh, can we also have that? Can we also have that? And then we tried to generalize it. The algorithm wasn't as accurate for everybody, obviously, and there's certain things that have to be adapted to that. And the knowledge of the particular workforce, like be it software developers, let's say, be it salesperson and so on, can help us really to make that algorithm better and make the measure focus better. So for software developers, it's easier for us because we have a very good understanding of what do they mean as being productive.
So you could have a different profile. I mean, different knowledge workers might spend different times in different apps. The notion of the app in which they're doing their core work versus an app where they're getting information or searching, you could have these sort of things, they would naturally vary.
Yeah,
like
absolutely.
Stack Overflow is relevant for developers. You see a person in Stack Overflow, you sort of know what they're up to, right? But you don't expect like maybe a data scientist.
Yep.
Maybe they have some Stack Overflow, but maybe there's some other side to it.
Yeah, so it is true. So some of these definitely are, or we hope that in the future we might generalize them as well.
Okay.
For the biometric sensing, on the other hand, some of the things are obviously very specific, like measuring the code difficulty that they experience, and we didn't just track the biometric sensors, but also the elements that we're working with, correlating those ones. It's very specific to software developers. Yeah.
I think it'd be really interesting if you pivoted this on context, on based of whether somebody's working in an open plan office versus working in an individual office.
Yep.
Because there's not much studies on this, and yet everyone's going to open plan. So.
Yep. No, it's super interesting, and people have mentioned that before. And obviously, there was multiple approaches before we set the Focuslight, for example, into place, where people said, well, how they try to reduce the interruptions, and they said, oh, since we used before, and I would just close my door, like turn off the light so that nobody would know that I'm in the office, which is obviously not always working when they do it for 2 hours. Some people would actually put up really big pylons on their desk, so these construction pylons to show other people, and they said that generally open to the open office, it made it sometimes more, like there were a lot more interruptions. But for some people, it was also really beneficial to sort of like be close to the people and just shout over and talk to them. It would be in the future, since we have so many people, at some point interesting to really analyze the differences. But we had just started, and I think the more data we gather, the more we can run these analyses over the different populations.
Yeah, first of all, I really like the idea of the Focuslight, and just like I think that's a very concrete finding, which says that like you can use this, you can use a focus light, and the people who used it, liked it because they used greater than 75% of the time. So afterwards, that's like, good retainability. That's awesome. One of my questions is about your measures to assess productivity, specifically the kind of a trend of the measures. So like in the statistics you gave were the expected, just the mean value for the star rating of that out of 5 of like that measure. So for instance, the number of work items I closed on that slide. And then you also gave a standard deviation and you showed 2 of them. So I'm wondering, can you maybe talk about the data of all these measures, or are these just 2 measures? You said you did.
We had
many
23
measures,
metrics overall, like the lines of code, for example, that they created a day, the number of key the work items that they created. I don't recall all of them. Like they're in the paper, and I should have some more in my head. But there's sort of like 23 that we thought of came from the literature and also thought of before, and that might make sense to measure your own productivity. And what turns out in the end is that there wasn't one clear winner or something, like the step count. This would be a good thing for my activity. He wasn't like even the number of work items. Not everybody was happy with that because they said it really depends on the difficulty of the work item and so on. And so in the end, most people had their own sort of set of features or set of metrics that would help them the best to understand their productivity.
Yes, but for this example, it seems like the number of work items dominates the time I spent in meetings because the mean value is greater and the standard deviation is lower.
Absolutely. So this one was the most prominent one, and the other ones are really all the other ones were a little bit less, but all of them around 3.3 or so. So they were all very similar. Like the number of work items was the one that stood out by having a higher mean value than the others, but the other ones were all very, very similar, and it really just depended on the person.
Did you see or look for any clusters in sort of that denoted maybe personality types, like extroverts love meetings and introverts hate interruptions? And
We didn't do that so far yet, no.
okay.
But it's obviously an interesting research question, and we've thought about it, and Tom has thought about it too. There is like trying to figure out the personality traits and how they influence that. And there is certain personality traits, obviously. As you've seen with the productivity trends, like there's this morning people, evening people, and so on, and they might also affect how you want to measure when you want to be productive and so on.
But we actually did find some clusters in what people perceive as productive or not. So like this is one cluster was like people who perceive helping others as a productive use of their time, while others don't think it's so productive.
Are those documented in the
so for clusters, not yet. So if you email me, I can send you some.
Okay.
Do you or your team personally use this like sensing, like to track yourselves right now?
So I make my students use it. So Andrew built the retrospection app, and he's using it, Manuela is using it, so definitely we're using it within the team. I have a MacBook, it's only working for Windows, so I can't use it, unfortunately. I might, I know. I will most likely switch in the near future because I also wanted to set up the focus light and so on. But we also use the biometric sensors on us, and especially like the less invasive ones, we're just starting it up to wear these chest straps to sort of measure that over long term and correlate it with other things.
So sort of midway through the talk, when you was the end of the talk, I guess, when you talked about the setup with the biometric sensors and whatnot connected, right? So my understanding is that that's for a specific kind of straight line task, right? So there is what exactly is the task there that they have to
So we varied that really based on the study. So for the task difficulty, it was a controlled lab experiment, and we gave them these small tasks that I was talking about a little bit. Like they were 1 to 8 minute tasks because it was sort of like the initial controlled lab experiment. For this code quality concerns, we really had them work for 2 weeks, and we didn't enforce anything. They were just working on a normal task. We were just tracking the code elements they were working with, as well as the biometric sensors. So we had them sort of like the monitor installed in the IDE and the sensor, and so there wasn't any limitation on the task. For the interruptibility, we had a combined lab and field study. In the lab study, we gave them tasks, so sort of like open source GitHub tasks that others performed before on one project, 2 different tasks.
Like what?
I think for this one we used JHotDraw possibly. I don't recall the detail. Like JHotDraw project. the JHOT open source project, and then we had used 2 tasks that were open or that somebody fixed before, and then had them work on these tasks. But we sort of like tried to, in the end, it's like in the field, we had them again use their own tasks. So most of the time in the field for the 2 hours, they were really just working on their normal tasks, and we didn't enforce anything.
Well, I guess sort of it comes back to, you know, what I brought up earlier, which is the notion of productivity, I think, here is, I mean, not only is it subjective, but I mean, I think for most sort of like mid-career and above developers, they're involved in some number of projects. And sort of the straight line coding task is not quite an adequate notion of their overall productivity, because part of the reason they get interrupted is to unblock somebody in another project or what have you. And so the aggregate amount of productivity sort of that comes out of these individual tasks, I mean, the correlation there is obviously present, but it's a highly non-linear situation.
Absolutely. So I mean,
so you know, in a sense, you know, you want to measure the aggregate output, not what happens in a sprint. You want to look at the marathon.
Absolutely. So it's a good point. Obviously, like they are artificial in a sense when we did them in the lab, but for not all of them we measured productivity. So the productivity didn't come, like in this ones we tried to predict the code quality concerns. We didn't look at the overall productivity or the progress that they made over those 2 weeks. And for the small tasks we also didn't do that. But obviously we know that the artificial tasks are not easily to just generalize to the field, but I think that was a first step, and that's why we went to the field afterwards and had it for 2 hours. But like just to mention, like in all of these 3, we didn't measure productivity with the biometric sensors. We only measured how interruptible were you in the last case, how difficult was the task in the first case, and how much can we really predict the difficulty of the code element or the quality concerns that you're creating in the code element. But it's true, like obviously as you mentioned before, and I think there's a really interesting part about not just looking at small little productivity increments, but looking at the overall thing and looking at other measures. Like one of the things that people really mention is like, oh, can you correlate it to sort of like the business value that we create each week? But then they were like, when we talked to them as well, it's like creating a feature doesn't mean that's very productive because that feature might be tossed right after. So you almost have to have this really long-term horizon, like even after 6 months or something, where you can only at that point assess whether or not this was a productive period in time based on business value. So this is really difficult for any of the studies that we run at this point, but it is really interesting at some point when more people are using biometric sensors, and we could, for example, track it for a whole year and sort of do that in that case. Just an example. Cool.
Okay, so that's my comments.
Thank you so much.